What's going on, arcade nerds? In this video, I'm going to convert this common black and white monitor, vector monitor, and I'm going to make a color vector monitor out of it. Now keep in mind, what I'm going to show you in this video is completely reversible. You can put those parts right back in here and you're not ruining a monitor because you can always put those parts right back in. And the amount of modifications that we're going to do to this, alright, let me explain this. I haven't done this yet. I've never tried this yet. I just know it'll work, okay? So, in this video, you're going to be experimenting with me all the way to the end until we have that working on that tube, okay? But, I know it'll work. But the way I figure, what's in my mind, you're only going to need to solder one single wire to that to make that work. Now, all we're going to use is the deflection board. We're not going to need the tube, of course, because that's a black and white tube. We're not going to need the high voltage box, because that's for that tube. All we're going to use is this deflection board right here. This is it's an Electro Home 805 deflection board. The same modifications that I'm going to tell you will work with 19V2000, etc. Okay? So, the major thing that we don't have, if we use this, is spot killer. This spot killer circuit is designed to turn this beam off on this tube. And it actually deals with higher voltage. I'm going to mess with this, so we're going to shut off the low voltage inputs instead of the high voltage inputs, which should be just fine. And I'll show you my idea of what the circuit's going to look like here in a bit. And once again, I haven't tested any of this yet. But let me talk about this first. What parts do you need? Okay, this is important, and it's easy to find out which parts to use here. Okay, now often on a raster monitor or a television set, you can use a television set guts if you want, but I like the raster monitor parts because I can buy cap kits easily. Okay, often these flybacks will be switched by your horizontal output transistor, which controls the horizontal output and drives your flyback. Well, you don't want a monitor like that. And the way to find out is unplug the yoke coil. Well, you know what I mean? And turn on your original monitor. If you have a dot in the center of the screen, you can use that chassis. If you do not, if everything dies, high voltage and all, when you unplug the yoke coil, you can't use that chassis for what I'm going to do. Okay? Now, just for to help you guys out, the exact chassis I'm using is a Vision Pro. Hap Controls Vision Pro chassis. Though that should work just fine. Okay, so let me talk about what we're going to do with the power in. Okay. This deflection board originally ran off of a 60 volt center tap AC voltage, and that was okay because the yoke coil it used had high inductance. Okay, we're going to drive a lower inductance yoke off of this chassis, and so to compensate for the different style of yoke we're going to use, we're going to run this off of 50 volt center tap. So in other words, we're going to plug this into a color Atari vector game. Okay, you won't have to mess with the original transformer, nothing like that. This will plug directly into the original harness, which is a plus. But I don't know. I mean, you could test it, but I don't know if I would suggest running it long term on a 60 volt center tap system. Okay, you might be able to do it. I don't know. Like I said, this is all just going to be experiments. I guarantee at the end of this video you're going to see it working, but and I'm going to try to keep it simple. I'm not going to try to go in crazy depth to explain everything. I don't know, I mean, do you guys want me to go into crazy in-depth stuff? I mean, so anyways, so let's get started. The first thing I'm going to do is get rid of all this. And you know what, these black and white vector monitors, I don't know how you feel or not, but they're pretty common, they're not impossible to find. Now the color vector versions are kind of a pain in the ass. So what I'm going to do is, I don't have a tube that goes with this, but I do have this TV that I just took out of the trash. So I'm going to rewind this yoke to be used with a vector monitor. Now I'm not going to go into depth on how to rewind this yoke. But I am going to say I have another video on my channel where I talk about how to rewind a yoke to make for use with a vector monitor. But I will give you a tip. I'm going to wind this with 100 to 115 windings. Why so many? Because it will match this deflection board better than if I went with 70, 80, 60 windings. Okay, and I could go in depth, but I'm not going to. Just trust me. 100 plus, let's say anywhere from 100 to 120 windings is where you want to set with this deflection board. Okay, so let me think, what should I do first? You know what? I have an old empty metal frame, and I'm going to try to mount this and this on that metal frame, and I'm going to get this tube and put it in that metal frame. Alright, so the black and white deflection board is now mounted, and the original monitor board is now mounted. And what I did is I just basically drilled holes into the existing chassis, and I got a dry erase pen. I just kind of hit it with a razor blade to make risers, so this board doesn't actually ground out on the metal frame, which is important. So this is not the entirety of the Atari deflection circuit. What I need now is I need to connect from here and here transistors, deflection transistors. So here's a few ideas of what you could do. You could drill holes in the side of the metal case and mount your deflection transistors, which would be fine. I want to sink away the heat a little better than that. So I went in my parts drawer here, and I have this. This is an early heatsink for a Electro Home. And what I'm going to do is I'm going to put brand new transistors on it and figure out some way to mount it. I'll make my own harness. That way I don't ruin the original monitor that I'm stealing this part from. So I'll meet you back up in a minute. So anyways, long story short, you want to make sure these are connected just how they were to the original black and white monitor. Two transistors, and need to be attached to something that can pull the heat away from the transistors. Okay, so what I did is I screwed 2 holes into this aluminum heatsink, and I just put screws right through, machine screws right through this bracket into those holes. And so I still have my transistors connected properly. And yeah, so I think next I'm going to put this tube in this frame. Well, so now the tube is in the chassis. Now keep in mind here, soon I'm going to have to rewind this yoke, okay? But I do want to mention that obviously you connect your new chassis up to this just like normal, and you're going to want to connect your flyback wire up to the anode button just like normal, okay? So what I'm going to do is I'm debating. Let me show you this. You see this? This is the original. Oh, by the way, you're going to want to make this ground share the same ground as this. So this is grounded to the chassis. I may ground this, the ground wire to this. But let me explain what these wires do. All right, this is the pin out to the G05802. It's also the same pin out as the 19V2000, and these are what we're interested in. I don't care about 6.3 volt. I don't care about Z ground. I don't care about, I do care about X and Y, I'm sorry. I don't care about the heater. There's only a few things we're actually going to use. We're going to use pin 7, pin 10, and ground. So 7, 10, which one's ground? brain fart, and ground. Okay, and we're also going to use 5 and 6, pins 5, pin 6 for our X and Y. Now that is going to connect into this connector here, which will plug directly into an Atari chassis, or Atari wiring harness. Okay, now this is 13 and 15 are our AC, I believe 14 is center tap, and we're going to tap into 7 and 8, which is going to be our X and Y. And you know, you might want to throw in a couple extra grounds. Just one ground ought to do it. But what I'm going to do is you could make an adapter harness, or you could just, you know, tap the wires right into it. I'm going to try to find a Molex so I can make an adapter harness. But if I do not find that Molex, I may just tap right into the wiring harness, so that has its own plug. Now later on we're going to worry about red, green, and blue, but I'm not going to worry about it yet. I just want to get X and Y working first, and then I'll show you what to do with red, green, and blue. Okay, I have now rewound the yoke coil, and to be honest, I'm not too happy with the inner coil's inductance. It's a little high, a little higher than you want it to be. So one direction is going to be a little slower than I want it to be. But it may be close enough. We'll find out. Not everyone can measure inductance. But I will tell you something that you can get to be kind of close. You can measure the resistance across your coils on your yokes. And, you know, if you're around, I would say the inner yoke, I wouldn't go any higher than 3 ohms, but you'd be better off staying around 2 ohms. But inductance is a measurement of resistance in an AC circuit, which is what this is. But the resistance will give you an iffy, closey sort of measurement. But this one's 4.5 ohms, so it's a little off. But that's all right. Well, I'll figure it out. What else? As you can see, I wired in these wires right here. Now this is X and Y and whatever, and I went ahead and I converted to the you know, color Atari plug. And I was debating on using the red, green, and blue inputs that you would normally use for an arcade machine. But I thought, wait a minute, it's going to go through vertical and horizontal oscillators and all kinds of crap. I says, you know what? Let's just connect it directly to the neck board. So this is what I did. Let me zoom in and show you what I'm talking about. Move the camera stand here. I probed these pins going to the neck board. Neck board is right up here. Okay. This is red, green, and blue going to that connector, and I cut them off on the. See if I can turn this thing. I cut them off right here. They're just kind of dangling, and I just controlled this way directly to kind of bypass any other circuitry that's not needed here. Although the amplifier would have been kind of useful. You can't just do this with any old TV, and please don't just hack into your wiring if you don't know what you're doing. But I will say, if you really want to, you know what? Let me say it this way. Sometimes these yoke wires, these yokes will have actually colored wires. One wire will be red, one wire will be green, one wire will be blue. And if you want to, you can tap in that way, or you know, keep in mind there are inverted signals on some TVs and some monitors. So sometimes this may need to be, you know, positive 5 volts going to this to make it make a red color active, or it may need a ground to make that red color active. So that's a whole nother topic to look into. So, you know, I wouldn't suggest. The more I think about this, I'm going to say this isn't for the beginner. Anyone can do, but maybe if you follow what I'm doing here, maybe you'll figure it out this way. Also, let me tell you the pins on this. Let me move it over. Where am I at in the camera? Okay, the one to the far left is blue. The center wire right here is green, and this wire is red. Okay, so I tied those in, and I almost don't want to tell you this because I don't want everyone to get electrocuted here. But I'll tell you how I found out that those are red, green, and blue. What I did is I turned the monitor on, blank screen, no raster, no nothing, and I connected a 9-volt battery, and I grounded the negative terminal to the chassis, and I got the positive terminal to a 330 ohm resistor. And that 330 ohm resistor, I touched each of these pins until I seen red, green, or blue flashes on the screen. And so then I knew, okay, so if it was that bright with 9 volts, I'm assuming it's 5 volts is where it should be. So, because remember, the signals from your Sega vectors are TTL level 5 volt signals. So, yeah, so let me hook this thing up and let's see what happens. Okay, before I tell you, before I show you the front, I want to make note that this is the D-Gauss coil, which corrects your colors, okay? And this plug is different than my D-Gauss connector, which is right here, next to that resistor there. And so I'm going to have to replace this connector or whatever. Anyways, I need to connect a proper D-Gauss coil to this for it to work properly. But I have it hooked up here, and I see some issues. First, let me see, there's Lunar Battle. Obviously the colors are wrong because, you know, I can't degauss the screen. But that's not a big deal. The big deal is the wiggles in the vector. Do you see it? And I have two theories on why I have the vector wiggles. Theory number one, this coil I use is just too much. It's not the coil. Let me say it this way: the coil could be wrong. Okay. Number one, I have a few different ideas. Number two, my high voltage is too close to the yoke. That's very well possible. There's an electromagnetic field around this you know, flyback that could possibly affect your input levels or your yoke itself. Another theory is none of these wires are all loose and dangling, and I don't have any twisted pairs here. So it's a very high possibility that you know, these wires are picking up noise and interference from each other by the time they get to the top. So let me see what I can do to clean up this picture a little bit. And now we have perfect picture. What it was I rearranged this a little bit, and it did improve the picture some, but the real issue was one of my grounds wasn't connected over here. So that was that. Also, I don't have to plug this in anymore. That's no longer needed. All the adjustments can now be made on the neck. So I'm not too happy with this yoke, although the yoke is working. So whatever, I got a perfect picture out of it. It's a little out of spec, but hey, whatever, man. I mean, if you zip tie all this together and make it so it doesn't look like a piece of crap, hey man, we just made a color vector monitor with a, well, it's actually a combination of a TV set, an arcade monitor, and a black and white vector monitor parts. But hey, that's about it. If you guys like this kind of stuff, please subscribe. Have a good one. Wait a minute. What about spot killer? Okay, I'll tell you what to do. How to make a spot killer circuit. What we're going to do is we're going to hijack the original spot killer circuit. Now, if you don't know what spot killer does, what it does is it's a circuit that sends the signal output to your X and Y yoke, the signal output going to your yoke, okay? And what it'll do is it'll keep this transistor and this transistor active when there is a signal, okay? And when there is a signal, it will ground this out, going to the base of this transistor, okay? Well, since this is a 2N3906 transistor, we know when this base is grounded, it makes this transistor activate. Does that make sense? So, this goes from a 5-volt signal to a ground when the X and Y deflection is weak. So what I want you to do is I want you to solder a wire right here, and then I'll write a schematic and tell you what to do with it. Okay. Instead of connecting your red, green, blue directly up to the neck board, this is what we're going to do. We're going to have red, green, and blue. Okay, these are your inputs. Okay, we're going to have a resistor here. This will be a 330 ohm resistor. Okay, so will this, and so will this. Now, all these will be connected together after some 1N4148 diodes. Does that make sense? And here will be your red, green, and blue to the neck board. That ought to do it. And what that's going to do is when that grounds it out, it will ground the signal out after the 330 ohm resistors. That way it doesn't ground out your main board. And you know, these diodes will interconnect all three without actually connecting red and green or green and blue or so on. Does that make sense? Alright, have a good one.